Welcome to Installer Show 2024, the Heat Geek stand, where we're doing live podcasts for a bit of a change. We might even maybe take some questions if anyone wants to listen in from the side. This podcast is about should we be demand shifting specifically with heat pumps? That means shifting our heat pump usage around to help any imbalances in the grid. Already starting to sound complicated. I'm joined by Andy Regan from Nesta, very knowledgeable chap. Our pre-conversation already went into deep detail, which I just put pause on. Andy, very good to meet you in the flesh, finally. Could you give us like a little one-liner of who you are, how'd you end up where you are, and then maybe like an overview of the topic?
So, starting with me, I mean, I've been working on energy from like the policy end of the spectrum for just over a decade now. So I've worked for Citizens Advice, who, amongst all the other things that people know them for, they are like the statutory consumer body for the energy market. So loads of like policy research work for there. I spent a bit of time at Ofgem, at the energy regulator. I worked for a little think tank in Wales where we had a project about renewable energy and how we could use that to sort of stimulate the Welsh economy. And then after that, found myself at Nesta, where, for anybody who's not familiar with us, we're a charity focused on doing innovation projects around 3 missions. One of the missions is called A Sustainable Future, but it's 100% about speeding up the decarbonisation of emissions from homes, which means more heat pumps. And one of the things we're interested in, as well as growing heat pump uptake, is demand shifting from energy. So that's me.
Amazing. That's a really good collection of bits of experience culminated into one amazing person there. We're talking about demand shifting of heat pumps, which is controlling the heat pumps either externally, mainly externally, to shift the amount of electricity the home's drawing, right?
Yeah.
How do I explain this simply and why we're doing it?
I mean, so the most helpful thing is to zoom right out from homes and just think about the whole of the future of the system. So obviously we're at Installer Show. You're focused on what happens in homes. We're focused on it in a different way. Energy flexibility generally is something that policymakers are putting a huge amount of emphasis on because of what we think the future system will be like. So the main trend is going to be away from fossil fuels. That means heat demand being electrified. It means transport being electrified. It means industrial demand as much as possible being electrified. Implications of that, fairly obvious, is that we're going to need a whole lot more energy grid building. And just as you wouldn't want to meet the heat demand in a home from having the biggest possible heat pump and just sticking it in and running it hugely inefficiently, you don't want to do that with the grid either. You want it to be optimized as much as possible. So part of that is keeping overall demand as low as it can possibly be, but it also means you don't want to spec the entire grid to the times when it peaks. You want those peaks to be as flat as possible. So we know there's a peak demand from heat, there's peak demand across all of the kind of demand sources, and you want to flex that as much as possible. And flex basically just means using it at different times. So there's using less of it overall and using it at different times, because between now and the era when we have 100% kind of electrified generation mix, obviously if you're using energy away from peak times, it's more likely that energy will be clean, because the way it works on the system generation wise is you use nuclear power first, because it's not trivial to switch a nuclear power station on and off. Then you use all the renewable generation, because it's best to use that at the point that it's generated, and then whatever your shortfall is, you switch gas-fired power stations on. So if you don't have to do that because the demand's lower, then your electricity that everybody's using will be cleaner.
Amazing, very well explained. We use nuclear first. I never assumed that. I don't know why. And is that because it's a long kind of startup and wind down process, or what?
Yeah, I mean, I couldn't explain how you turn a nuclear power station on and off. I'm glad there are people who know how to do that, but it's not trivial to do that. So that's like your base load, if you like. Once it's up and running, it's up and running constantly. And wind and solar is variable.
Nuclear, I think, is 22 grams per kilowatt hour or somewhere around there.
Carbon intensity, yeah.
But I think wind is still like 13 or something. I don't know, off memory. It's not zero, right? Anyway, still minuscule.
Yeah.
Cool. So, getting to the meat, hopefully that explains it for everyone. Getting to the meat of the subject. Some of you may have seen the video I did on this subject, which explored the best tariffs for heat pumps, and specifically variable rate tariffs, which try and shift these people's homeowners' usage of their heat pump to areas where there's lower demand on the grid or a surplus of green electricity. And specifically, the gotcha in doing that is that the heat pump efficiency is quite dramatically reduced, depending on how much you're shifting the usage. So that video kind of summarizes that maybe it might not be the best idea. It does also say if you install a lower temperature system, which has much higher efficiency, there's loads more bandwidth. So if you install it super low temperature, 30 degrees, you can pretty much load shifters or move around your usage as much as you like with much less loss of efficiency. But most homes, Victorian homes in the UK, do need a higher temperature and do take this penalty, which means when the heat pump is on, it's more expensive for the homeowner, but also it's a bigger spike for the grid, right? And if we have it on constantly and more efficiently, it's kind of spread out more evenly over the thing. So I guess that would be my argument. I'm always very open-minded to change. And the other backdrop we point out in that video is commercial. That's another, I don't know, is that the same size as domestic draw on the grid?
As a percentage, off the top of my head, I don't know.
Right,
But
so
it's a huge
something
part,
like that,
yeah.
right? And then what's the impact there? I mean, where are you on this? You're midway through a study, I think, maybe.
Yeah.
Is there any early indication? Where do you personally think it's going to go?
Yeah.
What are the trip-up points?
Yeah, so I mean, unfortunately, we're not at the point where we can talk about the results from our study because they're all being QA'd at the moment. So I'm sure we'd be happy to stay tuned. We could come back and very happy to do that. So on the kind of overall, sticking with the overall picture for a moment. So yes, there are sources of demand that are going to be a lot easier to shift than home. So if you're running a factory, there's probably no reason you want your factory to be running during the day versus at night. So
Is this already implemented in commercial?
Yeah.
Oh,
So this isn't. It's not particularly a new thing. You know, if you had like a power cut or you thought there was a risk of the power cut, then the National Grid, the system operator, for a very long time has already been kind of pointing to like industrial demand sources to turn down.
So there's the capability of doing that is in commercial. Is the capability at the commercial premises and the want or desire at the commercial premises there being fully utilised, do you think?
I mean,
because I'm kind of seeing this with like consumer versus non-consumer, everyone's got to pull their weight, right?
Yeah, and I think, it's worth noting that it's not just about turning down, it's about turning up sometimes as well. So if you had like a surplus of wind generation, it makes just as much sense to say, well, okay, increase production in your factory. I think part of the point is, as well as managing the peaks, there's the concept of like system inertia, which is like it's literal inertia in the case of like a gas power station. Turn a gas power station off, or if there's like a problem with it, the turbines literally keep spinning, so they keep generating for an amount of time after something happens. Whereas with solar and wind, that's less of a factor. So not only is there more kind of variable output of the system, it also changes more quickly. So flexibility is needed in terms of like an instant response to manage the grid. So really, the mindset, again, at like a policy-making level, is as much ability to demand shift as possible can only be a good thing from a system management, reducing the cost. When we use energy is going to be much more of a factor in how much it costs than how much we use in the kind of end state that we're talking about, decades from now when it's all electrified. It's going to be much more important.
But we have another tool at our disposal, especially for those quick spikes, which is storage, right?
Yeah.
Do we have an indication of the trajectory of that growth? Is it that on a steep incline, or?
I think so. I remember when I was at Ofgem, one of the like fun quiz questions we had at like all staff away day was, what's the thing that you think would make the biggest difference to the energy system in future, and in cheap batteries came out at the top. So yes, battery technology is the obvious kind of thing.
Home and grid side, right?
At any level, if you could halve the price of a battery,
I would imagine grid side would be like the cheapest because of scale, right?
Yeah, and it's obviously easier to sort of dispatch it. Yeah. But again, it's like if you're trying to build in as much flexibility potential as possible, then batteries are the obvious thing. You can have it bi-directional. We know that there are types of electric vehicles that can, feed back into the grid as well as taking out from the grid. So it's all about like the flexibility potential of it, and we're still not quite at talking about heat pumps yet. But this is
no. Well, I was about to say.
Yeah.
What I was going to say was, before I feel like we want to cause effect to a homeowner in their home, we want to make sure these other things are on the way and being done, especially if we're going to project what's going to happen in 5 years' time. Because if we all focus on this one thing and we ignore the important thing over there, then we're missing a trick, right? We should be doing all of the parts. When you weigh up these other parts, which I do in that specific video, and then you look at the heat pump, you're like, well, there's a tiny amount of energy here. Vehicle charging, like you just said, 90 kilowatt hour battery, like that could run a heat pump continually for a day. So, when vehicle to grid comes in, how much is it really going to shift it? I'm not so sure. Batteries we had are going to make an impact. Grid side, industrial demand. Is there anything else?
There's interconnectors with other countries as well. With buying and selling through like huge cables under the sea. That's not a new thing, but we are building more of them. So you can trade between national markets and things like that. So
that sounds positive, but on the negative, we've got a lot more renewables going in, which means the spikes are going up and down even more higher rate than the solutions are going in, right?
Yeah, so there's managing the peaks and the fact that obviously every time the system operator has to do something to balance the system, that costs money, and that cost is passed on to customers. So in terms of domestic customers, one of the main things that an energy retailer, energy supplier does is try and anticipate how much energy the customers are going to use and buy it as far in advance as possible that they get the best price for it. And then having bought the energy that they'll be using in a year or two's time, they'll trade it with each other to sort of, in the wholesale market. And that becomes more, at the moment, obviously the fossil fuels are still a huge input to the price of electricity because we're using gas to generate it as well as burning it in our homes. We're quite heavily exposed to gas prices in the UK, which is why we've had a bit of a tougher time with the Ukraine war and the gas crisis than some other countries have. And that one of the interesting things, so in terms of what I was saying earlier about nuclear power gets used first, then renewables, then interconnectors, then gas, that also affects the overall price, because to avoid having a negative incentive against building a wind farm. So if you're a big multinational company looking at building power stations all over the world, looking at building them in the UK, you could invest in gas power stations or you could invest in wind farms. You don't want there to be a negative financial incentive to build a wind farm. So for that reason, all generators at any given moment in the grid get paid whatever the most expensive unit is costing. So that will be gas. 97% of the time, the half-hourly price in the energy market is set by gas power. Right. And that means that the energy coming from renewables, which is cheap, is getting paid what the gas gets paid. So it pushes up the price of the entire system.
Well, there's profit made in there, right, to somewhere?
Yeah.
And that just goes to, and it's not the energy companies, it's something above the energy companies? Well, I don't understand so that's where my understanding leaves.
Yeah, so there's profits at every point in the system. So obviously whoever is getting the gas out of the ground is making a profit on selling it. The network companies that are managing the system get a profit for, they don't profit from selling the gas, but they move it around and look after it, and the electricity network companies the same. Retailers make a profit by how they kind of buy and hedge. And
I need to go and do some study there because that sounds interesting. So energy providers, they buy at this gas set rate, and then if that wasn't set by gas and they bought cheaper electricity because it was half of renewables or whatever the cheaper sources were, that would give us more flexibility in pricing to maybe either penalise more in the bad times or give more discount or maybe even go to negative pricing more often.
There's a few different things in play here. So when I'm talking about this, the half-hourly price is being set by the gas price, that's at the moment that it's used.
Sorry, yeah, with you.
So if you didn't buy energy in advance and you bought it now, using it now, you would pay that final wholesale market price. So by buying it in advance, you're trying to hedge against whatever that price ends up being. But that still is the sort of settlement price. So there's two terms to explain maybe. So that the system operator does. There's balancing, which is making sure supply and demand are the same. or the grid collapses and
Yeah,
get frequency dropouts and problems like that. And then there's settlement, which is sorting out the payments for whatever the system operator has had to do to balance it. So as an energy supplier, you should be telling the system operator in advance what you think your customers are going to use. If you overestimate or underestimate that and they have to take action as a result, then you face a financial penalty for getting that wrong. So this is why we're getting smart meters, because having that half-hourly data for every user in every household will make that ability to predict usage so much easier.
Yeah, they're not trying to spy on you and make money out of you somehow. They're trying to help you.
We're trying to make money out of you, but part of the problem is you don't have visibility of what's being used.
That's a huge thing. Like the benefits there are far outweigh anything else.
And this is the bit that I keep almost getting to and sending myself off on a tangent is the flexibility is about ultimately the final cost of the system. So the mindset is that even if you have enough flexibility on the system, including from homes, it brings the total system costs down for everyone. So we'll come back to this, but if you had some households that were providing a chunk of flexibility, they would be bringing the prices down for other households who were not.
And even in the commercial sector or industrial sector?
And
which might make their products or produce cheaper, the net effects may go on, I don't know.
Yeah, I mean, and the optimistic scenario is it has a net effect on electricity prices, which is, it is good if electricity is cheaper. And there's lots of ways of, not having fossil fuels as an input to the wholesale price in the long term will make it cheaper too. And that's the point at which flexibility ceases to be a thing that's about like reducing carbon emissions, and it becomes just about price. And National Grid do some so National Grid system operator do some modelling every couple of years that they call future energy scenarios, where they look at different they tend to do like 4 different runs of 4 different versions of what the future might look like, where you get lots of this, less of that. And in a kind of high flexibility scenario, they again talk about all of the system. They anticipate that the savings could be like billions and billions annually forever from having a flexible energy system versus just sort of over-speccing it.
Conserving waste is just putting on that extra
efficiency. Savings. Like I say, just as you wouldn't like stick the biggest possible heat pump in, and you would. You don't want to over-spec that. You don't want to over-spec the grid either.
That's really good. Okay, so on that subject of forecasting in the future, right, I'm just going to give you like what I suppose instinctively think, maybe off the back of the video that I made. Can you pick holes in it? I believe that today demand shifting for heat pumps, to bring it back to the title, has some effect. The best really thing to do is maybe you turn it off for 2 or 3 hours a day. As time moves forward, in fact, actually, even today, if someone gets a battery in their home, automatically that will cover that 3 hours, so there's no shifting needed there. If you shift more than 3 hours or turn off more than 3 hours, generally speaking, you'll be paying more per year. At the moment, at the current variable rate tariffs, I haven't experimented with Agile, so maybe you could turn it off more with Agile. I think that actually is the case. Maybe it's up to 6 hours, but no more. Maybe that's enough. I don't know. But again, once you put a battery in a home, you don't need to do that because the battery can power the heat pump. So knowing that, and then also knowing vehicle to grid is coming, which is a battery that's much bigger than a normal home battery, up to 5, 6, 7 times as big. I can't ever see there being, because everyone's going to get an electric car, I believe. I can't ever seeing there be a case where I need to shift my demand from a heat pump unless my car's not plugged in and I don't have a battery. And all these other things that we talked about, grid side battery and commercial also aren't working. Because even if I don't have my car plugged in, my 2 neighbours might. So does that make sense? And what do you feel about that statement?
Yeah, and I see a lot of sense in it. So I'm definitely not here kind of saying, you're wrong, Adam, we definitely need to be flexing demand as much as possible. Because, I mean, and we'll come on to talk about the actual experiment that Nesta's been doing over the last couple of years, but we're trying to quantify this because everything I've just described is like it makes sense on paper. So that you can do all this stuff, like you can control demand. That's not in question, but how it sort of shakes out in terms of its true variables. Potential and real world variables, that's what we're trying to understand because there's lots of different interactions. I do kind of broadly buy it that the most having the potential to flex is valuable.
Yeah.
It's worth noting that for industrial users at the moment, there are what we call availability payments, as well as, I can't remember the term. So there's availability payment is if you are willing to turn off at a certain time, you will be paid purely for the willingness to turn off. If you then also do turn off, you get paid even more.
Wow.
So parsing that into homes, so you can imagine a situation where you've given your consent as a homeowner to say, right, flex my demand.
Right. You're giving that.
I'm allowing you either at any time you choose or at a fixed period.
That's
you
amazing.
as a third party, you can flex my demand. And it's over to you. You might get paid just for being willing to do it, and then even more if you did do it. And so you'd have a business that's like an aggregator of all demand that they could possibly get. And if there's a huge problem at the grid and they need an urgent response and they need every last kilowatt flex, but this would be an absolute edge case, right? But if they need it, it's there. You're not even getting paid for doing it.
Your risk factors go down, insurance bill. I don't know. There's all sorts of net effects.
So the potential is there, and I basically ultimately buy it that like heat pumps are going to be a tiny sliver of that. But at an aggregate level, when everybody has heat pumps, or most homes have their own heat pump, that obviously is a huge source of demand, and having it available is useful too.
I'm going to argue against myself because I do that all the time.
Okay.
I think I was wrong. If someone gets a battery, they get a battery to play with variable rate tariffs. If you're being charged through the nose, yes, you'll want to start depleting your battery. But to help conserve your energy or this capacity in your battery at that time, you may want to lower your temperature at that time to make sure that you've got enough. So it's probably not as simple as I was saying. It's an obvious thing now, but it's worth bearing that in mind. The reason you get a battery is to work with the flexibility and get paid for that flexibility, right?
Yeah.
And if it's done for that purpose, you want to be helping your battery because you get paid. So.
And it's, what do you as an individual homeowner think is going to happen in the next few days? If you think there's going to be a storm, you want your battery to be full of power that you can use. You don't want to dispatch it now. And it's, again, like how it's going to shake out. And we will get onto the trial we've been running, but there will be a trade-off between what you were arguing for in your YouTube video, which is the best COP and the best efficiency, and what you might be getting paid by your energy supplier for being available to flex and doing the flex. They might say, well, okay, it is running less efficiently, but I'm getting paid a few quid to run it inefficiently, so it nets off.
Well, is it less efficient?
Well,
if the grid is more efficient,
you're better placed.
Maybe Scott should include, I don't know, the grid efficiency. Kind of going off on a thing now.
A bit above my pay grade for that one, but I mean, maybe this is the moment to talk a bit about what we actually have been doing, because there's a bit in this that we need to talk about. So we've been doing a trial that we're calling Heat Flex. We're working with an organisation called Centre for Net Zero, who are part of the Octopus Group. They're like an independent research unit, sits within Octopus. So all the people in this trial are Octopus customers, and we are, Nesta and Centre for Net Zero are controlling these people's heat pumps. So we've run it last winter just gone with a decent sample size of a randomised control group. So some participants who are having like heat flex events, which I'll explain what that is in a moment, some who aren't. We're comparing them to get a properly kind of statistically robust answer to the question of like how much demand shift can you achieve by doing this. And the doing this is overheating the home before the peak period and then underheating it during the peak period. So the way we're doing that, which I know Heat Geeks will be interested in, because I'm aware there's different ways that you could be varying what a heat pump consumes. It's always the first question we get from installers. We're doing it by varying the set point on a smart thermostat. We're using a Tardo, which is not what a Tardo is for, and we know that that's not necessarily the most efficient way of doing it. But that's what we had to do to make the trial work.
I see that as a trial.
So we're sort of telling the Tardo before.
I got one question on that. It might be a bit specific for you. Is the Tardo, and this is obviously being trialled with heat pumps, is the Tardo connected via bus connection to the... So what that means is, so this is going to be worth looking into. Someone probably knows. And this is just for the viewers' information. If the Tardo is connected via an on-off switch, it's not going to be a very a very good real world example, just like we were saying about paper exercises before. If it's connected via bus, actually, I think that's a good method, increasing in 1 degree, because the flow temperature will just gently rise if it's weather compensated, rather than, oh no, the house was at temperature, now it's not at temperature, come on, full beans. It has to be in like a modulated control environment.
Yeah.
One's very efficient, and if it's wired in via bus, how it should be, your results will be a lot better than if it was wired in via on-off. Probably is modulated, I just wanted to make that point, because it's an important one for everyone to understand.
Yeah. I'm not 100% sure. I'll stick my neck out and say I don't think we're doing the second option. I can check with the team, and it can pop a little caption saying Andy was wrong about this. But
what heat pumps they are, or can you say?
So we've taken the approach of trying to do it with anyone who put themselves forward.
On-off switching.
So yeah.
On-off switching.
So
it's a shame.
And it, with there's no kind of criticism implied of the technology. It hasn't worked with every heat pump because it's not designed to do what we're trying to do with it. So
and if it works with that less efficient way, then it definitely works with the more efficient way. So it still gives us a baseline to work off.
And this is it. So the purpose of the trial, we know it's lo-fi, but it's the best we can do now because we're trying to answer a question now about the future.
That's great data.
Because so we're testing for the pure turn down potential, including the preheat phase. There's a big assumption in Carbon Budget 6 from the Climate Change Committee, so the advisory body that tells UK government like what it needs to plan for in order to meet net zero targets. They've made a big assumption about the flexibility potential of homes. That something like 90% of homes will be able to successfully preheat and avoid demand at the peak period by overheating and stable.
How long's the peak period for? 3 hours?
In our trial, we've done 2-hour windows. So we did 2 hours of preheating, 2 hours of turn down, and then looking at the period 2 hours after. You can argue it's 3 hours in real life. But
I did a trial period in my house for 3 hours for 1 week.
Yeah.
And it's a brick 1927 building.
Yeah.
And I lost 0.75 degrees of temperature.
Yeah.
I didn't even need to preheat. I just didn't even notice the temperature had gone. I just turned it off during that time.
Yeah.
So I already know that worked.
Yeah. So there are other trials that.
And like my Scott did lower because it did have to work harder when it was, to get back up temperature.
Yeah.
So just to make that clear.
Yeah. So there are other trials that are testing this as well. There's one called Equinox, which is much larger scale. That's run by National Grid Energy Distribution and a few other partners. They're not using preheating in their trial, and they're not using automation. So there's more people looking at this, but we were particularly interested in preheating because it's a big part of the carbon budget pathway, and automation because we believe it's going to be a bigger part of how this happens.
Yeah. So you're looking at the capacity here rather than is it going to be doable, or are people going to accept it, or anything. It's more how much room is there to quantify how much effort we put into it. Is that fair to say?
So we are looking at those things too. So the absolute headline kind of question of the trial is how many kilowatt hours of demand shift do we get? That's where all the kind of heavyweight data analysis is going to. But we are also looking at are we compromising thermal comfort? Are we making people too hot in the preheat period, too cold during the turn down period? And we're doing that by surveying them and with lots of interviews before, during and after the trial, and we're looking at acceptability of the automation and the overall thing. So are people happy with the idea of somebody else turning their heat pump on and off, up and down, and messing with it on their behalf?
I've got another statement, and this one I have definitely thought of for a long time, and I think it does. The whole thing comes down to this: is that of course it's doable to make everyone. You could probably make everyone turn off all their heating during the day and have it overheated at night if you paid them enough. But that's the point. If you paid them enough, isn't this just down to how much the variable rate tariffs vary their rates? If you're going into -1p overnight, people are going to overheat their rooms, their houses at night. Obviously, you don't want windows open. Ignore that. And if you're charging, £3 a kilowatt hour during the day, they're going to turn off the heating during the day. So, or is that going to be? I mean, I suppose that'd have to be an opt-in. Isn't this just down to how much we vary the tariffs, and then we don't even think about SCOP? Like that's just a bypass, by the by.
Yeah, I mean, obviously, you'd always want to install to have the potential to get the best SCOP.
But the beauty is the best SCOP installations will have the best SCOPs if they were controlled like that.
Yeah, and this was my question for you when we spoke the other day: is would you actually install a heat pump system differently?
Yeah, right.
To unlock this flexibility potential? Your answer was basically no.
Exactly the same. It's exactly
which is good news, really,
Yeah.
because it was a sort of, if you stick with the mindset that like flexibility is good and you want to lock as much as possible, then knowing that actually the best kind of steady state heating system and the best flexible heating system don't need to look different is useful. Because then it is just down to consumer motivation and payments.
And if the grid is looking balanced and you can keep the heating on evenly, you're going to absorb that extra capacity that or efficiency from the heat pump back into the grid.
Yeah.
So and once smart metering is sort of 60% at the moment, smart meters homes, right?
Something like that. Yeah.
And there's a bit more perhaps intel on heat pump performance. That information will be calculated in like the overall master algorithm, right?
Yeah.
So it's a bit of a feedback loop.
I mean, and your point a moment ago about essentially like modulating overnight, kind of, that speaks to like, when would your car charge? Like if your car can talk to the grid, the grid can say, just hang on, wait a few minutes, wait an hour and charge then. You don't care as long as it's charged up to 100% by the time you want to get in and drive it in the morning. You don't care exactly what time during the night, but you do care when your home is hot. So exactly. And actually our experiment is more about managing that huge peak in demand and the assumption. And as your point earlier about your own experiment at home, fabric is going to play a huge role in it.
Exactly.
If your home can retain the heat, then you can. You might not even need to overheat.
So this is something that needs to be understood, I think, by most people in this industry. It's retaining the heat. People think that my home, it must have been well insulated. No, it's thermal mass. So you have thermal inertia, which is made up of insulation and thermal mass. My house is poorly insulated, but it has high thermal mass. Basically, high thermal mass means that it has brick interior walls, which can drink up the heat during the day. And then if I turn off my heating for 3 hours, it takes a long time to drain that heat out of those walls and it radiates back into the house. So that's an important thing for people to realize. Dr. Michael Harper, our data scientist, uses Next, who's Eon Next tariff, cheap night rate one, an expensive day, and he basically overheats his house during the night, turns it off during the day, and has a really unhappy missus, but a really fun experiment. Again, he gets the same, he must be really well insulated. No, it's a 1960s build, pretty old double glazing. It has basic insulation. It's just because it's made of brick. It gets to absorb that. And new build houses, which is very little of, we're not building. Most houses have that thermal mass. They can't cope in the same way, but thankfully there's less of them.
Yeah, interesting. And this is the bit where I'm really interested in your take on these things, because I think there's for good reasons, there's a lot of like pessimism about fabric. Kind of you encounter this in the kind of, no, you can't possibly put a heat pump into a home unless you've wrapped the whole thing in
exactly.
layers and layers of insulation, and that plays into this debate as well. And it's part of what we're trying to establish, and what the other trials are trying to establish is, is it as bad? Like, can homes actually retain heat for this relatively short amount of time? And again,
I think the results will surprise.
It's probably partly this thing that comes up so often about like using heat pumps like boilers, because this wouldn't work in the same way as it would with a boiler, where you're heating the air rather than the walls, if I've understood correctly. If your heat pump has stored up a huge amount of heat in the thermal mass of the fabric, and you turn it on for 2 hours, that's different. And if you've just heated the air, and you lose all that heat through airflow. So again, our trial is about understanding how it works in the real world.
I know where your trial's going to go within 2 years.
Okay.
You're going to be researching not the heat pump, but the flow temperature of the system.
Yeah.
So if you look at the last graph on the video of demand shifting, you'll see a series of lines which show the lowest line is a 50-degree system. And then we put like a red line at the bottom, which means once you get down to this point, the heat pump won't work. Like it's too hot. The flow temperature is too hot to heat the home. It will start faulting. It will have all sorts of issues. These other lines that sit above that, they're lower temperature systems. So they've got more capacity to keep the home warm and higher SCOPs. But the moment you drop below this certain point, you're going to have complaints. So the flow temperature will indicate at capacity. Anyway, the point is, heat pump is only part of the system. And the system is largely reflected by the radiator sizes. You have to look at the package rather than the individual tiny spec.
One protection. I'm partly sort of nodding and smiling about a lot of that, but the overall sort of system design being I guess, but it comes down to that point earlier about like the marginality of it. Like if you just need a little bit more turn up or turn down at a system
fair.
level in
Yeah.
a really extreme event, and all that's left is heat pumps and controlling them directly, that is going to be worth potentially quite a lot of money. If it's like that or a power cut, and this would happen like a tiny percentage of the time, but the ability, being able to call on it, I'm talking like decades from now, it's worth designing the system around that rather than just being like, oh, let's have 3 times more grid than we actually need. And
One thing I totally agree with, it's definitely worth looking into and doing that exact study than going, no, I don't think so, because you're not going to get anywhere. We have to be looking at these things. So I think I generally agree. I want to get our kind of final answer to the question together. But first of all, is there anything else we've been missing from our jigsaw piece that we've kind of built?
I think the thing I'd like to throw into the mix, which again we're just starting to look at, is the question of fairness in this whole thing, because our experiment is with Octopus customers who have heat pumps in 2022, 3, 4, and are willing to sign up for a trial with an organisation like Nesta and Centre for Net Zero. So people in that position tend to be more affluent. Lots of our participants in the trial have batteries, so they are, we're trying to understand how that's interacting with the heat pump. Some of them have solar panels. Some of them have really bespoke systems that they've designed themselves.
Yeah.
So we're really conscious that you can't, if we had we absolutely got huge amounts of turn down and they all loved it and were super happy with it, it would be a big mistake to sort of generalize and go, question answer, move on, let's just build a whole system around it. There's people who are not going to get a heat pump for a long time. They're not going to live in a home that retains heat in quite the same way. A lot of those people will also be on much lower incomes, much less engaged, harder to they don't have the luxury of spending
and
time
there's much more of those people by a huge margin.
So the decisions that we kind of make in the next few years about how the system will work and how energy retailers design the front end of all of this. So things like Octopus have saving sessions, OVO have a thing that does this, Utility have power payback. There's all kinds of other stuff, which is the front end of those payments that are coming from National Grid at the moment to sort of test this in principle. If there's something about the way that is designed that doesn't work for people on low incomes, or people who have particular health needs, or people who have small children who will have their bath at 6 o'clock, whether the energy is expensive or not. Or if it doesn't work for them, then you're going to lock in a lot of unfairness. If people are getting paid a couple of quid every time they turn up or down, that's a problem. It's not fair. So we're starting to look at that from 2 angles. One of which is sort of how do you increase access to low carbon technologies that give you the ability to flex. And there's a lot of that happening in social housing. So a lot of people in social housing are getting, grant-funded heat pumps and systems going into their homes, as well as nice fabric upgrades. So that's good. But there's some challenges around making sure people feel confident using that new system and not running it like a boiler, getting the best possible advice and support. If they're then also expected to participate in flexibility markets, or they get talked into going onto a tariff that's supposed to incentivize that, but they don't actually understand what they're supposed to do, and so they use it the same, but they then just getting overcharged during a peak period because they're not sure about whether they're supposed to turn down or not. That's another source of unfairness. So we're working with Utilita to just understand how some of their customers have found their experiences of that power payback scheme that they run, and really small scale, only talking about a dozen interviews, to start thinking about, well, do you need to design these products differently to make sure they're available to everybody? Because we don't want it to be yet another thing from the clean energy transition, thinking about feed-in tariffs for solar that mostly benefit the most affluent, engaged households. There's a long legacy of that happening, and it'd be nice to avoid it this time. So,
that's true. Okay, that's a really, really good point. Yes, one I hadn't thought before. Annoyingly, I think we really agree a lot, which means it's not very contentious. Why don't you shoot for a summary, and I'll see if I can add to it.
So we should be trying to unlock that potential as much as possible, even if heat pumps are not one of the biggest ways that we are demand shifting in the long term. It's super plausible to me that having a battery on the wall of your home, having a vehicle to grid car in your driveway, that will be doing more demand flexing for you than your heat pump will directly. But given that you've told me you don't have to do anything differently really to be able to use your heat pump in that way. So having a service from your energy supplier that can call on your heat pump to do it when it's actually needed and gives you that option, it's another way you can opt in. That will probably be worth it, but you have to make it easy.
This is a piece of a jigsaw, along with all the other pieces.
Yeah.
You need all the pieces to make the picture. With the slight twist, and I think I'd actually like your point on this, so we might have to overrun slightly. I think a signal can be sent to homes to pull back demand or encourage more demand. I think it would be down to the local HEMS in the home understanding what's in that home and how it's being used to decide how that's achieved, rather than an external signal talking to all their heating, because that person might have a car plugged in, so they know they don't need to reduce the heating. It makes much more sense it be done on a localized level. Still, that study would be needed to be able to total up the whole thing, but I think it should be done more on a picture of the system in the household, which includes the SCOP because of the system radiator sizes, etc. And then there can be an intelligent HEMS type platform. Maybe it's just in the cloud. It probably will just be in the cloud. That will decide the best things to switch off or how much the switch will turn down by. And the homeowner will be able to say, if they're really temperature sensitive, no, that's the only thing I don't want, or yes, I'll have loads of flex there, but I do need my car at this time because I have an emergency. I think that will be the actual solution. Just a more electricity or less electricity to every individual home, then a local decision.
Yeah, I basically 100% agree with that. So the message that gets sent to the home is just going to be, can you provide me this much turn up or turn down?
Yeah.
The system doesn't care whether that comes from a heat pump or a PlayStation or a fridge. It doesn't care. Yeah. So yes, some sort of device that you can either just be like, I don't care what you do.
Yeah.
I'm easy. Or yes, don't compromise my thermal comfort. Don't mess with my car. You can't do it at such a time because we've got the family visiting and we're cooking a roast. Whatever.
Yeah.
Whatever level of control. But that's where different sort of smart tech companies and app companies and energy suppliers will innovate around people who want super, super grain of control, people who are like, no, never, I'm never going to let you do that ever, let 1,000 flowers bloom kind of thing.
I think we actually answered this question, which I didn't think was answerable because there's too many variables. And the answer is, should we demand shift with heat pumps? The answer is, it depends. There's no panacea, which is our company motto. And it depends on that specific homeowner, and it will be decided on each home. So should we demand shift? Ask the homeowner.
Yeah. Well, that's
for that homeowner.
Yeah.
Not all homeowners, the individual one.
Yeah.
Right?
That's what it always
is. Nice simple summary is
ask them.
Like, subscribe, and see you on the next one.